This is Knowledge Engineering with Semantic Web Technologies. This is lecture number 5, Ontological Engineering. And this is the extra part, or the start of the extra part of this lecture, which is not part of the official OpenHPI course, but it is fit to deepen your knowledge in specific areas which are of importance, like, for example, ontology design. And for that reason, we want to talk today about further ontology design methodologies. Okay, as you might remember, we have already talked about design methodologies, like, for example, Ontology 101. These design methodologies, they had the purpose that, for example, they should help you to efficiently design your ontologies, not to make common mistakes, to avoid mistakes, to save costs that are somehow connected to this development process, and also to enable distributed collaboration, for example. But the methodology we have talked about, Ontology 101, usually is only suited for smaller kind of ontologies, and of course it's not a real professional design methodology. So for that reason, we want to have, again, a look on two further design methodologies. First is called Upon, and the other one is called Ontology Design Patterns. Okay, so let's start. First one, Upon. It's of course an acronym, and the entire name reads Unified Process for Ontology Building, and it has been introduced in 2005. So what is it all about? So the nice thing about that is, of course, it reflects on experience that we already have from software development and software engineering. So therefore, it's based on a methodology from software development. And this methodology is called Unified Process. And what they use for representation here is, for example, the Unified Modeling Language, which of course is used in software engineering. So for software engineers, this kind of methodology should be rather familiar. One thing that we do have to say in advance is it's a use case driven methodology, so it's better suited for application ontologies than for domain ontologies. So if you have a specific application in mind, this kind of methodology works much better than, for example, when you try to describe and represent an entire domain of knowledge. It has the following goals. Of course, we have talked about that. Like all of the other methodologies, it should, of course, work on a reduction of time and cost that is somehow based in the development process, especially of large-scale ontologies. And then, of course, it should somehow guarantee a quality improvement of the developed ontologies. What you do there is you do a progressive validation. Also, your intermediate results are already evaluated, and then, of course, you try to improve it step by step further. And then, of course, it should also foster collaboration, especially efficient collaboration between the two groups who are always involved in the ontology design process, which are on the one hand, the knowledge engineers, who will build up the ontology, and the domain experts who provide the knowledge from which the ontology has to be built up. And here, of course, the roles are clearly separated. So we will have a look on that also. And of course, the nice thing here is already intermediate results can be evaluated by the user. So not in the end, but also during the course of the process. And this, of course, is one of the strengths of this approach. Okay, let's have a look at the process. The Upon process usually is divided into so-called cycles, which repeat and repeat. And each of these cycles usually is divided up into 4 phases of iterations. And these phases are inception, the first one, elaboration, then we work upon that, construction, there we build something, and then transition, which means transition to the next phase. And each of these iterations usually consists of 5 different workflows that you also see here in the graphics. Each iteration starts with a requirement. So you look at the requirements for this ontology, for this specific application that you build. Then you do an analysis step where you try to gather knowledge. Then you do design, which means you try to construct somehow your semantic network. You implement it in a special, of course, ontology design language like OWL, for example. And then, of course, you have to evaluate and to test your ontology. So this is, again, a cycle and a cycle. And the interesting thing here is, so during the workflows, the workflows during the phases here, they are somehow or almost orthogonal, which means the involvement of the single workflows in different phases of the ontology development, it varies. And you see this here in this nice graphics. You see here on the x-axis, you have the different phases, starting with inception, then elaboration, construction, and transition. And then you see the workflows for each of the iterations. You have here requirements, analysis, design, implementation, and test. And what you can see here now from iteration to iteration, of course, the involvement of the workflows varies. Of course, in the inception phase, right in the beginning, of course, you do a lot of requirement stuff. Again, also you start already with analysis, gathering knowledge, and you only do rather little of design and almost no implementation and testing. This comes then in the second phase. So if you look at the elaboration phase, requirements are still going on, then you do the most of your analysis, gathering knowledge here, and you of course start to design your network. And of course already you try to do first implementations, and you also try here first evaluations, first tests on what you have already designed. And so on and so on. So in the construction phase, you see then, of course, the requirements now drop down. Also, the analysis is almost done. The semantic network still has to be constructed. And of course, the coding process, the implementation process is full at run. And then, of course, during the transition phase, which is the last phase you see here, of course, most of what is done is here testing and evaluation. Of course, the other activities then are only minor. And you see here on the right side of the screen, you see here a graph which shows the involvement of the two groups who are here involved in that process. DE, it's the domain expert, it's the solid line. And you have KE, which is the knowledge engineer, and this is the dashed line. So let's have a look at here. During the requirement phase, of course, the domain experts are involved because they have the knowledge that they have to provide. And if you go on in the workflows, for example, if it comes closer to the design and implementation workflow, of course, the involvement of the knowledge engineer then increases. And then you see again a drop for the knowledge engineers and an increase for the domain experts when it comes to testing, because both of them then have to work together. So this is an overview of the overall process. Let's go into these single workflows. Okay, we start with a requirement workflow. Usually what you have here as an input are interviews with the domain experts. You have some application-specific documentation and stuff like that. And you use this, you write storyboards, you define business purpose and stuff like this. And then you try to create some output of that. You try to develop an application lexicon, which somehow, of course, describes for what kind of use this ontology is intended. And in the same case or in the same workflow, you also start to work on your competency questions. You remember competency questions are questions which the ontology that has to be developed here in that process should answer in the end. And you try to develop use cases. Where is this ontology with your application in mind? Where is it really deployed, or how is it deployed, for example? So and you see here, of course, again, the domain experts are involved when here knowledge is gathered, and then when the output is created, of course, the participation of the knowledge engineers increases. Okay, we go one step further, the analysis workflow. There you take, of course, things from the previous workflow into account, so existing external resources like documents, standards, or already existing technologies which might be there, and you take the application lexicon which has been developed. And from that you are trying to build a so-called domain lexicon which describes somehow the domain you are working in, and you try to build a so-called reference lexicon. And in this reference lexicon, of course, the most important terms will be gathered. And then you start, of course, for the application you have in mind, to draw class diagrams and to draw activity diagrams with UML, with the Unified Modeling Language, and you try to develop a so-called reference glossary, which then will be the standard reference for all your terms in your ontology. So this is the analysis workflow. And here again, you see first the domain experts are involved most, and then, of course, both meet domain experts and knowledge engineers. They both are or participate here in the production of these outputs. The next step then is design. And of course, here then the knowledge engineers are involved. They take the reference glossary with all the necessary terms, and they take the UML diagrams that tell you how these things really somehow are related to each other. And they try to start modeling concepts, modeling concept hierarchies and domain-specific relationships and stuff like that. And the output of that process is already a semantic network. So it's an ontology, but not necessarily a formal ontology, which is already given in some kind of logic or in some kind of language like OWL. So it's a conceptual thing. So first a semantic network, which will be output of this design workflow. The next thing, of course, you have to take into account this design, this semantic network, and you have to implement it with a specific formal language. So you have to find out which is the right language that I should use. So how expressive should the logic be that is involved in the design of that ontology? And then you try to formalize your concepts, for example, with OWL or with one of the OWL dialects, with the OWL profile. So it of course depends on the expressivity that you need for the application you have in mind. And again, you see here the knowledge engineer is the one who runs that process. The domain expert in this specific workflow has not very much to do. But this changes then if it comes to testing and evaluation. And here, of course, then the developed OWL ontology is the input of the process. And then you do first things like consistency checking. This can be in an automated way, and of course it's supervised by the knowledge engineers. And then you try to verify the coverage of your ontology, and you try to answer all these competence questions. And of course there again you need the domain expert who considers whether the answer that the ontology delivers is correct and of course is complete. So it must be consistent and complete. So knowledge engineer and domain expert exactly here, they are working together. And in the end, you get the output, an ontology test, and of course the verified and tested ontology. And based on your results, so your evaluation, for example, says that you have to adapt, you have to upgrade your ontology, you have to complement your ontology, then you enter the next iteration of that cycle, until, of course, you are content with the test result that you achieve here. So that's the unified process for ontology building, the upon methodology. Okay, but as you can imagine, there are lots of different methodologies that have been proposed for building ontologies. But very often you might think, yeah, so many things are connected to each other. Somehow everything relates to each other. So if I have a specific ontology in mind for a specific application, potentially there has been somebody who has already found something which I can use. So this reuse thing would be an interesting thing to follow. So I do not have to reinvent the wheel every time, and it would be somehow nice if there would be something like a toolbox for standard situations that I can choose ontology building blocks to build up my ontology. And exactly that approach is something I want to show you, and this is called ontology design patterns. So the next point here, or the next methodology, is called ontology design patterns. It's also introduced in 2005, and as you might imagine, of course, the idea is not new for ontology. So this has already been developed, for example, in architecture. There is some architect who is called Christopher Alexander, and he developed something which is called design patterns. So this is adapting an idea which originally comes here from architecture. And it's about recurring modeling problems. You provide a set of adaptable standard solutions for that problems. And for this, patterns are defined. And a pattern there is a solution to a problem in a given context. And originally, this Christopher Alexander has published a book, a design pattern language, in which he said the elements of this language that he has developed are entities called patterns. And each pattern describes a problem that occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use the solution 1,000,000 times over without ever doing it the same twice or the same way twice. So it's a standard pattern-based solution that you use, and of course you're simply adapting that principle also to ontology design. So you are using so-called ontology design patterns, and they provide small, reusable, abstract ontology templates with an explicit documentation. And of course, they are all gathered in a searchable repository, and this repository is organized with the help of competence questions, simply because these competence questions will help you to find the correct, the matching building blocks for your ontology. So you have a specific basic problem, of course, you have to match it to some kind of ontology questions or competence questions which should be answered with that small kind of ontology. And this is the kind of mapping you are looking for. So if you have the same question to solve in mind, simply you can look it up in a repository, which again maps this question to some basic templates that you can use for building your ontology. So that's the foundation or the foundational thought of and design principle of exactly that methodology. So for this, they distinguish several kinds of ontology design patterns. So there are content patterns, which are usually somehow domain-dependent, language-independent. So these are patterns which fit into some domain. And there are logical patterns, which are, on the other hand, domain-independent. And they are related, on the other hand, to the representation of language somehow. So they closely interact with each other. Usually these content patterns are somehow instances of then logical patterns. And you have presentation patterns, which somehow give you an aspect of ontology from the user perspective, like, for example, different naming conventions. And you have transformation patterns, which are somehow able to transform an ontology from one representation into another. So the basic two design directives or design principle building blocks here are logical ontology design patterns and content ontology design patterns, and they are connected with each other like I told you before. So the content design patterns are instantiations or instances of logical design patterns or compositions of logical design patterns. And there are much more. You see here a class hierarchy of the available or right now available ontology design pattern types that are available. But the most interesting here are the content ODPs. So how does this process of selecting the right pattern work? So I can give you a rough idea about that. So usually, if you try to model a problem, you have two components in your content ontology design patterns. You have first the domain, so where this application really will work or is carried out. So, and in the same domain, of course, you might have different requirements. So they specify in the end the design pattern that you have to use. On the other hand, of course, there are recurrent requirements which can be found in different domains. So domains and requirements are things that are somehow to be represented for your content design pattern. And a typical way to capture these requirements that you have is by means, of course, of competency questions. So we already had this. So the competency questions are the key to your design patterns that you look for. What you do then is, of course, all these content design patterns are collected and they are described in some kind of catalog or huge repository. And of course, they comply then to a common presentation template. Let's have a look at an example. So I want to somehow model a fact like Basil Rathbone played Sherlock Holmes in the 1939 movie The Hound of the Baskervilles. So what I want to model here is exactly this. Somebody is taking over a temporary role, which means Basil Rathbone played a specific character in that 1939 movie. So what I have to do is first I have to analyze the sentence here which covers or which contains the knowledge that has to be represented. So the point is somehow I have to match exactly that what is in that sentence to some kind of competence question. So you see here the repository on the right side, and the lower part of the repository, which describes the problem space, gathers all the available competency questions. And somehow you must map your basic sentence that you have here to a competency question that is about that a person plays a character. And if you found it somewhere in your problem space, usually you have mappings between the competency questions and the ontology design patterns, which are then in the solution space. This is the upper part of this repository. And in between you see these connections, these links, which connect ontology design patterns to the appropriate competency questions. So you try to find the right competency questions, and this competency question usually suggests one, sometimes also different, or sometimes some ontology design patterns. And then you can select which to choose. So for example, you have found here an ontology design pattern which is described with represent objects and roles they play. And you see here how in this diagram how this is represented. And if it fits to your purposes, you simply can take over this ontology template for your ontology. And of course, then you can represent this fact exactly with the according ontology design pattern. Of course, this only works when you have, or if you have a sufficiently large repository. And of course, there is one. If you go here to ontologydesignpatterns.org, you will find a huge repository with ontology design patterns. And of course, you will find lots of specifications and also how-tos and best practices and everything what is going on in design pattern research. So this might be an interesting resource for you. So these were two additional methodologies that we wanted to cover in this extra part of the lecture. The point is, of course, you can develop an ontology for a given problem. But in the end, you must have some means to decide whether this is a good ontology or whether this ontology has some flaws. So the next point that we want to cover is ontology evaluation. We have already talked about the basics of ontology evaluation, but what we haven't talked about are specifics about that.